Hey guys, in this video we're going to look through lesson 10, which is about compound inequalities. So compound just means that it's going to be more than one. When we look through this here, I want you to take a look at this do now for a second. So we're determining if each of the following statements is true or false. So in this first one here, we're given Albany is the capital of New York and New York City is the capital of New York. So when I read through that, if it says and, it's saying that both things must be true. So Albany is the capital, but New York City is definitely not. So they can't both be the capital, so that first one's going to be false. But then in part B, it says Albany is the capital of New York or New York City is the capital of New York. Well, we know that Albany is the capital of New York. So since that's true, at least one part is true, and it's kind of comparing like this or that. So since Albany is the capital of New York, we're going to say that one is true. Now, the next one says Poughkeepsie is the capital of New York or New York City is the capital of New York. Well, we already said that Albany was the capital of New York. So Poughkeepsie is not true. New York City is not true. So neither one of those is true. So this one's going to have to be false. And then for part D, it says Miss Bies is a math teacher, which hopefully we all know is true. And Miss Bies' favorite show is Scooby-Doo. If you don't know by now, it's definitely true. So since both parts are true, we can say D is true. Now, that idea and that concept alone is what we're going to look at today. We're going to take two inequalities and compare and see if, when we put them together, the overall idea is true. So in exercise 1, we're considering each of the following compound, which just means more than one, inequality statements, determine the truth value of both inequalities, and then determine the overall truth value. So as we look through these here, 7 is greater than 3. Well, that's true. 2 is less than 10. That's also true. So I have something that's true and true, right? I want to make sure both things are true. So overall, this whole thing will definitely be true. For B, it says 5 is less than 10, which is true, and 11 is greater than 20. Now that's false. That's not true. So it says that those two things both happen, right? Like 5 is less than 10 and 11 is greater than 20. Well, with the and statement, as soon as one of them's not true, it makes the whole compound inequality false. Okay? Just like the first one of our do now. In C, we have -4 is less than 7, which is true, and 8 is less than 2, which is false. But here, when it says -4 less than 7 or 8 is less than 2, or means as long as one of them are true, the whole thing will be true. And finally, we have 3 is greater than 6, which is false, or 8 is less than 5, which is also false. So since there's nothing true about this statement, even though it's an or, it is false. And as we continue with that idea here in exercise 2, which of the following inequalities is false? And we're going to explain as we do this one. So, same thing again, we have 5 is greater than 2, which is true, or 4 is less than 1, which is false. But really, as soon as I saw that there was a true, when it's an or statement, it's like this or that. As long as there's one component, that's good. It's true. So overall, that would have been true. So 1 is out. In number 2, we have -6 is less than 5, which is definitely true. And 7 is greater than or equal to 7, which is also true. So we have true and true. Everything is true, so that and is okay, and we're good. In 3, we have -2 is less than 4, which is true, and 5 is greater than 7. Now 5 is not greater than 7, so we run into a problem there. 3 is false. Then I could check my last one. 10 is greater than 0. -3 is less than 9. So that would have been, as long as you had 1, that was okay. The problem is, the explanation that we really want to cover in here is that whenever you have an and, that means both have to be true for it to be true. Okay, because if I want to say that the overall idea is true, it's saying this and that have to happen, right? Like Miss Byes is your math teacher, true. And her favorite show is Scooby-Doo. Both things were true, so we said that was good. If it's an or, you kind of have more options. You're like, oh, we could do this or that. You're not as picky. But when you have and, you're saying that everything's got to happen. Like, I want dinner and ice cream. You want to get both of those things, so you need both of those statements to be true. Okay? That brings us down here to our little rule here. So these truth values for and or. So one, if you have a compound and statement, it will be true only if all of the individual statements are true. So and is like the more picky one. So this and that happening, you need everything involved to happen. The compound or is a little more relaxed. It's going to be okay as long as you have at least one thing that's true in there. So we're going to look more at that on the next page here. Now we can find the solution sets of equations and inequalities, right? We know it's a value of a variable. A value of a variable is in the solution set of an equation or an inequality if it makes it true. And it is not when it makes it false. So we just check that our statements are true here. So in this first one, we're going to check if we plug in 2. So 2 greater than negative 3. Well, that is true. Then we look at x less than 5. So 2 less than 5. That's also true. Because and is there, we would need both. So both things are true. We're having a good time. So we could say yes. Okay. X equals 2 is in the solution set because it satisfied everything. It had to have that x was greater than negative 3 and less than 5. So it had to be something in between there. Next one, if x is less than or equal to negative 4, 4 is less than or equal to negative 4. Well, we know that is false. But then 4 is greater than 0, so that's true. Now, in here, sorry, my wording got a little bit cut off. It was supposed to say or there. But since it's or, as long as you have at least one thing that satisfies, we can say that this is true. Okay? Because you have two different options. You either have that x is less than or equal to negative 4, which it wasn't, so we were in trouble. But then 4 is greater than 0, so as long as you have one that satisfies, we're good. So we know that for or. Okay, I'm going to continue in that party in here. So in this case, I'm plugging in 1. So 3 times 1 plus 8 is greater than 9. So I'm going to get 3 plus 8 is greater than 9. 11 is greater than 9. So we know that is true. Do the same thing. Negative 2 times 1 plus 10 is less than 7. So negative 2 plus 10 is less than 7. We get 8 less than 7, so we have false. Now, the problem here is that we're given 2, and when you're given and means I need it to be true and true, right? I need both inequalities to be true. I'm looking for both pieces to check like this and that. So we have one, we don't have the other, so unfortunately, no. X equals 1 is not in the solution set. Okay, and one last time, 2 times 5, subtract 1 is less than 3. 10 subtract 1 is less than 3. 9 subtract 1, 9 less than 3. We're looking at false. So if it was and, we could stop right there. I wouldn't even need to go any further. However, we're dealing with or, so as long as one of them are true, we have the potential. So we're going to try this one out. 5 plus 7 divided by 2 equals 6. So 12 divided by 2 is equal to 6. So we threw an equation in here. 6 is equal to 6. That is true. So because I had an equal equation, we know that at least one of them were true. So we're going to say yes. Now we're going to see what this looks like on a number line here, like we were doing in class today. So in this case, now let me draw something for you first before you copy in these notes. Of course, you could always do a quick erase if you wanted to, but x has to be less than 7. So x has to be less than 7. Remember, at 7, we're going to have an open circle. Okay, only when there's a line underneath for the or equal to do we draw a closed circle. But in here, we have open circle at 7. Then it's less than, so we can follow that arrow direction. So we know it's somewhere along this way. But the other part of it is we need some kind of restriction, because at -2, we know it's at x is either greater than or equal to -2. So that would go this way. But remember, I can't just keep drawing these lines everywhere I want, right? I need it to be within those two. I need both to be satisfied because of, again, our favorite word here, and. So and means both need to be true. So there's a select amount that are going to have all true. So I'm going to go in again, and that x less than 7, that's going to stay open. So that's my open circle at 7. Now, here, x is greater than or equal to -2. I'm going to draw in our dot here. Now, the pieces that satisfy or makes them both happy, so it's anything in the middle there. So that would be how we would draw it on our number line, right? Because we have set rules. Okay, so it can't go further, right? Because if I had something outside, like if I had, let's say in this case, I know it's going to be from -2 to 7. Let's say I just tried to plug in for fun a -7. So if I plugged in this -7 over here, I know it would work for one. -7 is less than 7. But if I plugged in -7 greater than or equal to -2, that's not true, right? That's false. So as soon as you have one false thing, it doesn't satisfy both. So that's why we don't draw our pictures on forever. We only can draw them so it satisfied both equations, or both inequalities. Okay. So now I'm going to follow this up one more time. Now in the next one, we have x is greater than or equal to 5, or x is less than -1. So we have a different situation here. So either one of these will get us a solution. So x is greater than or equal to 5. So we're going to color in our dot here. Remember our trick with our arrow, it's pointing to the left. So we're going to point to the left also, because anything greater than 5 is going to be in the solution set. However, we also have some more to that solution set. We have x is less than -1. So at -1, remember, we have the open circle, but anything in this direction will count too. So and is the more restrictive, right? It's got to be inclusive. It's got to be inside those like that kind of boundary it's set up, right? So between -2 and 7 was part A. But for B, it can have infinitely many solutions, but it just can't have a certain part in the middle, right? So I can test that just to check here. If I picked one of these middle terms, like let's say I picked 3. So 3 greater than or equal to 5, automatically no good, right? So that one did not work. And if I try 3 is less than -1, that also didn't work. So it didn't satisfy either of them. That's why 3 over here, it's not going to be in the solution set. I could do that again for one that is. So in this case, if I like plugged in 6, 6 is greater than or equal to 5. But 6 is not less than -1. But remember that or term means I need at least one. I don't need both. So that's why as long as you satisfy one, and each one is kind of showing the graph of satisfying one and not the other. Okay. All right, guys, thanks for watching. In class tomorrow, we will be doing practice of this and all the other inequalities we've started.